Welcome to section 4.2, trigonometric functions defined on the unit circle. Here are the objectives for this lesson. You will find that this lesson is very important because it's basically the fundamentals that you'll need for the remainder of the course. Knowing and being familiar with the unit circle is absolutely crucial. With this being said, this information here talks about what the unit circle is. Basically, the unit circle has a radius of 1, and that radius of 1 tells us that every point that lies on this circle with a radius of 1 takes on this equation here. From this, we learn more information. Here, basically, this shows us the unit circle, and it may be helpful to read the information on starting on page 462. But basically, what this is saying, this piece here is really important. So typically we have coordinates of x, comma, y. Well, now we are going to have coordinates cosine of t, comma, sine of t. So whatever value is typically in the x position is the cosine value, and whatever coordinate is in the y position is now going to be the sine value. So here, that's what is being said over here. And then tangent, you will see, is y over x, which is also sine of t over cosine of t. And that's going to come up again, and you might want to remember that. So here it is expanded a little bit more. We had all of this on the previous slide, and now we are addressing 3 more trig functions. So there are a total of 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. And what you'll find is that sine and cosecant are reciprocals. Remember, a reciprocal, if I have the fraction 2/3, the reciprocal is 3/2. So sine and cosecant are reciprocals. Likewise, cosine and secant are reciprocals. And then tangent and cotangent are reciprocals. So the nice thing is if you know any of these 3, you can certainly find the 6 remaining as well. Another thing you can think of, since y represents sine of t, you can think of cosecant as 1 over sine. Secant is 1 over cosine. Oops. And then cotangent is cotangent over sine. Okay, and these will come up again. So you'll want to begin to become pretty familiar with these. Here's our first example. It says that we have this ordered pair on the unit circle. So this is the ordered pair that's given to us. It tells us it is on the unit circle. And we want to evaluate sine, cosine, and tangent. Well, recall that whatever value is in the x position is cosine, and whatever is in the y position is sine. So I know these 2 right away. I can say that sine of t is equal to -12 over 13. Cosine of t is 5/13 from the ordered pair. And then tangent's a little more complicated, but I want to remind you that tangent is sine of t over cosine of t. We know each of these, so if I plug them in, sine of t over cosine of t, These both have a denominator of 13, so they cancel, giving me negative 12/5 for the value for tangent of t. Okay, so here's another example. This one is similar, but now we want to identify the 6 trig functions. So we want to find sine, cosine, and tangent, as well as secant, cosecant, and cotangent. So we should know from this ordered pair right away what cosine and sine are. So cosine of t is in the x position, which in this case is the square root of 5/5. Sine of t is in the y position, which is 2 root 5/5. Recall that with tangent, there's a little more involved. Tangent is sine over cosine. In this case, they both have a denominator of 5. So this simplifies to 2 root 5/5 root 5. And then the root 5's cancel, so tangent of t is 2. As mentioned previously, if I know each of these 3 trig functions, I can find the other 6 by taking the reciprocal of them. Remember that the reciprocal of cosine is secant. So I can take the reciprocal of root 5/5 to get 5 over root 5. Remember to rationalize the denominator. I will take the square root of 5 and multiply that on the top and the bottom. This gives me 5 root 5/5. The 5's cancel, leaving me with root 5 for secant of t. The reciprocal for sine of t is cosecant of t. Taking the reciprocal of what I have there and multiplying by root 5 on the top and the bottom to rationalize the denominator, I end up with 5 root 5/2 times 5. So the 5's cancel, leaving me with root 5/2. And then finally, cotangent is the reciprocal of tangent. The reciprocal of 2, or 2/1, is 1/2. And here are the 6 trig functions given this point on the unit circle. Now, we will come across some really important values on the unit circle. And oftentimes they're referred to special values. And those special values will have central angles of pi/4, pi/6, and pi/3. And basically how these are achieved is by taking the special right triangles and kind of arranging them on the unit circle so that you can find the associated ordered pairs. And here's basically what I mean. So here you can see that if this angle here is pi/4, I want you to know that pi/4 is equivalent to 45 degrees. And you can make that conversion by taking pi/4 times 180/pi from the previous lesson. And you will find that this is 45 degrees. Well, if you have this triangle in here, this triangle, if this is 90 degrees and this is 45 degrees, then this angle must also be 45 degrees. And you may recall from geometry that if you have a 45, 45, 90 triangle, these sides are congruent. So call this length 1. If this and this are congruent, then that means that x must equal y. So I can apply this formula, x squared plus y squared is equal to 1. But since x and y are the same, I can say x squared plus x squared is equal to 1, or 2x squared is equal to 1. Divide both sides by 2, and x squared is a half. So then I can take the square root of both sides and find that x is this, or what I have here and here. And then if you rationalize the denominator, you will get these. Now remember, this is the x value. This is the y value. So this is cosine of t. This is sine of t. The same approach can be taken for a 30, 60, 90 triangle. Same approach. So if I take this triangle here, if this is 30 degrees, 90 degrees, this must be 60 degrees. And if this is x and this is y, if this is 1, then this big triangle ends up being an equilateral triangle. So this whole side is 1, so half is going to be y. So if this is 1/2, then you can put this into the formula. X squared plus 1/2 squared is equal to 1 squared. And then you can find that x is √3/2. Okay, and that's just where these values are coming from. So what this comes down to is that all of these special angles are going to have an associated ordered pair. Now, some teachers get all hung up on showing this and making you remember that way. I'm not that kind of teacher, but I do think it's important that you see where these ordered pairs come from. So a similar style triangle can be shown for pi/3. So again, I've already mentioned, but any angle will have a corresponding set of coordinates. And this is where the unit circle comes from. Okay, so if I were you, I would take like a screenshot of this or something, find one online, but you absolutely need to know this. The nice thing about this unit circle is that if you know quadrant 1, you know everything. So there's a lot of symmetry involved. If you look here, these are multiples of pi/3. Again, multiples of pi/3. Every multiple of pi/3 is going to have some form of this corresponding ordered pair. It just depends on where in the unit circle that falls. You may recall from your algebra courses that anything in the first quadrant, the x and the y coordinates are both positive. And you can see here that all of these coordinates are positive. In quadrant 2, over here, the x coordinate is negative and the y coordinate is positive. And you can see how that's illustrated with the trig, the ordered pairs associated with these trig values. Finally, in this third quadrant, both are negative, and then we have positive and negative. Okay, so the multiples of pi/3 are always this ordered pair, but depending on which quadrant you're in, the sign may change. Now, the way I remember this is that pi/3, the first coordinate is 1/2 because 1 plus 2 is 3. Again, the way I remember it, the first coordinate is 1/2 because 1 plus 2 is 3. And then the second coordinate is √3/2. On the other hand, if you look at multiples of pi/6, multiples of pi/6, let's find all of those, will take on the ordered pair root 3 over 2, 1/2. Depending on which quadrant they're in, the sign may change. Now, I know that this is the corresponding ordered pair because 3 times 2 is 6. So root 3 over 2 is the first coordinate. Students seem to do okay with pi over 4. Pi over 4, the corresponding ordered pair, both the sine and cosine values are the same. So all multiples of pi over 4 are here. Okay, so what we'll be doing is we will be determining what multiple of pi we are dealing with, which quadrant it's in, and then we should go from there. A couple other things are the quadrantal angles. Those are here. This ordered pair is 0, 0 or 1, 0. Likewise, because the radius of the unit circle is 1. Okay. So we need to figure out how we are going to use this unit circle. And here we go. It says identify the ordered pair on the unit circle that corresponds to the number t equals 5 pi over 3, and then evaluate sine of t and secant of t. So what I want to do first is notice that this is a multiple of pi over 3. Any multiple of pi over 3 is going to take on some form of the ordered pair 1/2 root 3 over 2. The way I know that is the x coordinate is 1 plus 2, which is 3, and the denominator here is 3. So I know that it's going to be some form of this ordered pair. I just have to decide which quadrant 5 pi over 3 falls in and what that does to the sign. So 5 pi over 3. 5 pi, if I'm talking about a revolution on the unit circle, it is positive, so I'm going to head in the counterclockwise direction. As I'm heading in that direction, I notice that 5 pi over 3 is not quite 6 pi over 3. It's less than that. And 6 pi over 3 is 2 pi. And I should know that 2 pi is 1 full revolution. So that means as I'm revolving about the unit circle, it is not quite 1 full revolution. It stops shy of that, which means 5 pi over 3 is in quadrant 4. And I know that in quadrant 4, x is positive, y is negative, which means 1/2 is positive, root 3 over 2 is negative. So this ordered pair will help me answer anything else I need to know about 5 pi over 3. First, I want to find sine of t. Remember, the second coordinate is associated to sine, so sine of t, and t in this case is 5 pi over 3, is equal to negative root 3 over 2. Secant, on the other hand, I want to remind you, is the reciprocal of cosine. So 1 over cosine of 5 pi over 3. We should know that cosine of 5 pi over 3, that's the x-coordinate, is 1 over 1/2. The reciprocal of 1/2 is 2. So secant of 5 pi over 3 is 2. Here is another example. So we're going to take the same approach. First, identify what it is a multiple of. In this case, it's a multiple of pi over 6. Pi over 6 is associated with the ordered pair root 3 over 2, 1/2. Remember, 3 times 2 is 6, so it is some form of this. Now I have to determine which quadrant this angle is in order to figure out the signs associated with this. Now, Pay attention because we have a negative value here, which means we are going to be traveling in the clockwise position. And 5 pi over 6 is not quite, 6 pi over 6, which is just pi. So since 5 pi over 6 is just shy of pi, that means when I am traveling, I'm going to stop short of pi, which means this angle is in quadrant 3. And in quadrant 3, both sine and cosine are negative. So this is the corresponding ordered pair. Once I know this ordered pair, I can find anything that I'm asked about it. The 6 trig functions. This, remember, is cosine. This is sine. So with that information, cosine of t is negative root 3 over 2. Tangent of t, remember, is sine over cosine. A negative over a negative is positive. The 2's cancel, so this is 1 over root 3. Rationalizing the denominator, I end up with root 3 over 3. And that's done. Okay, so let's give this one a try. I'm not going to do part B because we've done lots of these. So in this case, we want to find the 6 trig functions that are associated with 5 pi over 6. So in this case here, pi over 6 is has this corresponding ordered pair. 5 pi over 6 is not quite 6 pi over 6. So we know that this is in quadrant 2. And in quadrant 2, x is negative, y is positive. So I'm going to find cosine, sine, and tangent. Once I have these, I can find the reciprocal. Cosine is negative root 3 over 2, right here. Sine is a half, right here. And then tangent is sine over cosine, which gives me negative root 3 over 3 once I rationalize the denominator. The reciprocal of cosine is secant. When I take the reciprocal of that, I have negative 2 over root 3, but then I want to rationalize the denominator, and this will give me 2 root 3, and it's negative over 3. Cosecant of t is 2, because it's the reciprocal. And then finally, the reciprocal of tangent is cotangent, and this will give me negative 3 over root 3, rationalize. So negative 3 root 3 over 3, the 3's cancel, giving me negative root 3. And there you have it. We are interested in the domains of the trig functions, and I want to remind you that the domain, those are the x values. There are no restrictions to the domain for sine and cosine. Now, the other trig functions have some restrictions. And it's all kind of put together here a little bit, but basically those restrictions will come on the quadrantal angles, which are basically on these. And the reason for that is because if I want to find some of the trig functions, the reciprocal may have 0 in the denominator. And if that's the case, or the value itself may have 0 in the denominator, and anytime we divide by 0, the value is undefined. Remember, you can have any value you want in the numerator. Call it n. If 0 is in the denominator, no, the value is undefined. On the other hand, if you have 0 in the numerator and any number you want in the bottom, call it k, then it is okay, and the result is 0. That's all that's happening here, is it just wants you to pay attention that if we have something on one of these 4 angles, it is possible that we will end up with something undefined. That is again discussed here, and then on this slide, it's all put together. So if you look at this slide, you'll be able to tell that each of these different values are undefined when the denominator is 0. So with that being said, we have this chart here, and basically, as mentioned previously, sine and cosine, the domain is all real numbers, so there's no restriction. Tangent and secant, you want to be cautious of odd multiples of pi over 2. So that would be 3 pi over 2, 5 pi over 2, so on and so forth. These take place here and here. Whenever you have one of these angles, you'll be dividing by 0, which means it's undefined. And then multiples of pi would be here and here. Okay, so just be cautious. Here's what I mean. Here is an example of how this will be used. It says evaluate the 6 trig functions given these values for t. Okay, so negative 2 pi. If I think of a unit circle, negative 2 pi, we're traveling in the negative direction, 1 full revolution. So we start here, 1 full revolution puts me right back to where I started at the ordered pair 0, 1. I'm sorry, 1, 0. So I know this is cosine and this is sine. So if I want to find these 6 trig functions, cosine of t is 1, sine of t is 0. Tangent of t, remember, is sine over cosine. This is okay. The result is 0. The reciprocal of cosine is secant, which is 1 over 1, which is just 1. Cosecant is the reciprocal of sine. Well, if sine is 0 over 1, I can write this as 1 over 0. Anything over 0 is undefined. So cosecant is undefined. Similarly, cotangent is the reciprocal of tangent, which is also 1 over 0 or undefined. And that's all I mean. You may want to pause the video and give this second one a try. 3 pi over 2 is located right here. This ordered pair is 0, negative 1. So if I know that coordinate, I can go ahead and find all of the 6 trig functions. Cosine is the first value of the ordered pair, which is 0. Sine is the second value. Tangent is sine over cosine, which is undefined. Secant is the reciprocal of cosine. I can put cosine over 1. If I flip this, I have 1 over 0, which means secant is also undefined. Cosecant is the reciprocal of sine, which is also negative 1. And then cotangent is 0 over negative 1, which is 0. We've talked a lot about reciprocals already. This chart basically tells you about the reciprocals. I've mentioned it many times, so you can pause here and just see each of these reciprocals. Each of these are important. However you can remember this, remember it, because it will come up many, many, many times. Here's an example. It says sine of t is 15 over 17 and cosine of t is 8 over 17. Use the reciprocal and quotient identities to find tangent and cosecant. Okay, well, as mentioned previously, tangent is sine over cosine. We know each of these, so plugging them in, 15 over 17 divided by 8 over 17. In this case, same denominator cancels, so 15 over 8 is the value for tangent. When I want to find cosecant, I know cosecant is the reciprocal of sine, or 1 over sine. So sine is already given to me as a fraction, so the reciprocal of that is a little bit easier, which is just 17 over 15. That's it, nothing crazy here. Here we have the fundamental trig identities. These are very, 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 very important. You will see these again if you move on to take calculus. So definitely remember these. All of these basically stem from this one here. And I just want to remind you that on the unit circle we had x squared plus y squared is equal to 1. Well, all we've done is we have replaced x with cosine and y with sine. Additionally, these two identities come from this first one here, because what I can do is I can write this as 1 over cosecant of theta, square it, and then 1 over sine of theta. Actually, let's do it this way. I take it back. Let's divide. This is probably easier. Let's divide. So then this is 1, everything, sorry, is divided. So this is 1 plus, this gives me cotangent squared, and this is cosecant squared, which is this here. On the other hand, if I take this original identity and divide everything by cosine squared, I will end up with this identity. So that's where they come from. I'm not super concerned about that, but you will want to know how to use them. Here's one example of using these identities. We're given secant, and we are interested in this interval, and we want to find tangent of t. So there is a lot going on, but let's just take some baby steps. Now, we know that secant of t is the square root of 11 over 3, and we want to find tangent. So if we're given information regarding secant and we want to find tangent, we're going to want to use tangent squared plus 1 is equal to secant squared. Now, this theta, this angle measure here and here, you always need to write that angle measure. You can't just have tangent squared with nothing following it. Theta is known as the argument of the trig function. Okay, so we are going to use this formula and plug in the information that we know. So tangent squared of theta plus 1 is equal to, well, secant is the square root 11 over 3. So I'm going to replace secant with root 11 over 3. When I square each of these, since this is division, I can square the top and the bottom. So I have tangent squared plus 1 is equal to 11 over 9. I'm going to try to get tangent by itself, so I'm going to subtract 1. And if I'm subtracting 1 from 11/9, I'm going to rewrite this 1 as 9/9. 9/9 is the same thing as 1. So tangent squared of theta is equal to 2/9. Now to get rid of a square, I'm going to square root it. And remember, when you take the square root of something, you need to remember the plus and the minus. So I end up with tangent of theta is equal to plus or minus the square root of 2 over the square root of 9, which is 3. Now I have two answers for tangent, but I haven't utilized this interval yet. And this interval is telling me that I want values in between 3 pi over 2 and 2 pi. Now remember, this is one revolution of a unit circle, so I'm interested in the answer for tangent that is in the fourth quadrant. So in this case here, tangent is, let's see, in this quadrant we have this is positive, this is negative, and so in this quadrant, tangent is negative. So we will take the negative value. So tangent of theta is negative root 2 over 3. Let's look at another example. Go ahead and pause this and see if you can come up with a solution. Since we're given cosecant and we want to find cotangent, we are going to use 1 plus cotangent squared of theta is equal to cosecant squared of theta. Plugging in what I know for cosecant, I have 1 plus cotangent squared is equal to 5/4 squared. Proceeding and squaring each of these values, I get 25/16. I want to try to get cotangent by itself, and I'm going to do that by subtracting 1. When I subtract 1, I want to pay attention that my denominator is 16. So instead of writing -1, I'm going to say minus 16/16. So when I subtract that, I get 9/16. I will take the square root of both sides. Don't forget the plus or minus. So cotangent of theta is, remember I can take the square root of the top and the bottom because this is division, plus or minus 3/4. All right, so now I want to analyze this. Values in between pi over 2 and pi. This is pi over 2, this is pi, so I'm interested in values in the second quadrant. This is negative and positive. So here, cotangent is what we want to find. Cotangent is negative in quadrant 2. So I want the negative solution. So cotangent of theta is negative 3/4. And that's the type of thing you will see there. I apologize, this video is getting kind of long. Here it says for a given real number t, express tangent in terms of secant. All this means is you want tangent to equal something with secants in it, and it's some form of secant. Well, I know that the Pythagorean identity, tangent squared of theta plus 1 is equal to secant squared of theta. So what I need to do is I need to solve this and get tangent by itself. And the first thing I will do is subtract 1. Tangent squared of theta is equal to secant squared of theta minus 1. And now I can take the square root of both sides, not forgetting the plus or minus, and tangent of theta is equal to plus or minus root secant squared theta minus 1. Here I am done because I have tangent equal to something with secant in it. That's it. Even in odd functions and periodic functions, basically this is a little wordy, and I'm not super concerned about the wordiness. The thing that is important on this slide is this here. A period is basically like a full revolution or a full interval until it starts repeating itself. And this will be a little bit easier to see when we start graphing trig functions. But for now, just know that the period, before it begins to repeat itself, sine and cosine, cosecant and secant is 2 pi. Only tangent and cotangent have a period of pi. This is illustrated here in the chart. If you want to pause and look at this a little bit, you can. Now, I have a ton of examples of these, and I don't know if I'm going to do all of them because they're all very similar. So basically it says use the unit circle and the period of a function to evaluate the expression if possible. So for cosine, I know that the period of cosine is 2 pi. So what I can do is I can add 2 pi to this, which is simply 2 pi minus 7 pi over 4, or add 2 pi to this. And this gives me, I can think of this as 8 pi over 4. This reduces to pi over 4. So cosine of pi over 4. So now instead of using this, I'm using pi over 4. This is just kind of another way of finding a reference angle, really. Cosine of pi over 4, we should know, is root 2 over 2. Because the corresponding ordered pair with pi over 4 is root 2 over 2, root 2 over 2. Here, the period for tangent is pi. So I'll take pi minus pi over 2. This is pi over 2. So instead of using this negative pi over 2, I'll use what I just found. So tangent of pi over 2. Now remember, pi over 2 is right here with the ordered pair 0, 1. So tangent is undefined there. Okay, that's all that's really happening in these problems. Here, again, sine has a period of 2 pi, so I can take 17 pi over 6 minus 2 pi, which is 12 pi over 6, and this is 5 pi over 6. So really, I want to use 5 pi over 6 because it's just a little bit smaller and a little easier to manage in one revolution of the unit circle. So we've done this several times. You should first find the corresponding ordered pair for pi over 6, which is this. 5 pi over 6 is not quite 6 pi over 6, so it's in the second quadrant. So the first term is negative. Sine is the y value, so this is 1/2. If you want to try the other ones, that would be perfectly fine. I'll give you the answers. This one ends up being -2 root 3 over 3. Here we end up with root 3 over 3, and this one is undefined. And if you have questions on any of those, just let me know. Even and odd functions, we'll talk about this more in the future, but cosecant and secant are even functions. The others are odd. And again, I'm not too worried about that in this section. Finally, use a calculator to approximate these values. If the argument is in degrees, you should be in degree mode. If the argument is in radians, you should be in radian mode in your calculator. So here you will find that on your calculator you have cosine, sine, and tangent. So this you can just plug in right away in degree mode, end up with this. Then cosecant, we don't have a cosecant button, so you will have to do 1 divided by sine, because sine and cosecant are reciprocals of this. And when you do in radian mode, you should end up with this result. And that concludes the notes for section 4.2.